Welcome to episode 4. In episode 3, we defined EdgeProtect's annual selling model and base list price. Now we are converting the approved 250 endpoint policy into explicit pricing data that Salesforce can later evaluate. The rule is straightforward, but it must be modeled precisely. At 250 or more protective endpoints, EdgeProtect receives 15% discount. Crucially, that discount applies to all eligible units, not only to the unit after number 250. That makes it a range policy. Today, we create the schedule and tiers that store this policy. In the next episode, we'll build the pricing procedure that retrieves and applies it. By the end of this episode, you will know the difference between range and slab, create a volume price adjustment schedule, and constructive non-overlapping tiers, activate only after validation, and calculate the boundary result by hand. We are not creating a pricing procedure today. A schedule and its tiers are pricing data. A procedure is the runtime logic that maps transaction value, fetches the list price, looks up the tier, and produces the final result. Treating those as separate layers makes it much easier to find the cause of a pricing defect. This episode creates the policy. Episode 5 executes and simulates it. Use range value when one threshold determines one result for all qualifying units. Our 250 plus policy is range. At 249 endpoints, every unit is 240. At 250 endpoints, every unit is 204 after the 15% discount. Use slab when different portions of the quantity get different treatments. A slab policy might charge full service for the first 249 endpoints and discount only endpoint 250 onwards. That produces a very different total even when the threshold and the percentage look identical. This is not a technical preference, it is a commercial policy choice. Ask the pricing owner what the customer expects to see on the code and make the configuration match that answer. A pricing adjustment tier cannot stand alone. It needs a volume price adjustment schedule. It also needs a product and product selling model. Salesforce documentation calls out the pricing prerequisites. The product selling model and the product price book data must exist before you create volume tiers. For Cumulus Lab, those prerequisites come from episode 2 and 3. EdgeProtect platform is a commercial product. It has a term-based yearly option and it has an active standard price book list price of 240. This is why the course is built in order. Every configuration record has a business and technical dependency chain. The schedule is named Cumulus Edge Point, Cumulus Edge Protect Volume Discount. It has schedule type volume, adjustment method rate, and references the standard price book. We create it inactive, add and validate all tiers, then activate it. The schedule is the grouping record for one coherent policy. It lets the administrator see which product, pricing context, date range, and adjustment approach belong together. Do not overload one schedule with unrelated campaigns or expectation. Clear scope make later changes review possible. In our example, no effective end date is set, so the policy remains valid until a governed change replaces or retires it. We have two tier records. The first covers 1 through 249 and applies a 0% adjustment. The second begins at 250, has no upper bound, and applies a 15% discount adjustment. Both references EdgeProtect platform, term-based yearly, and the Cumulus schedule. The zero tier is intentional. It says exactly what happens below the threshold and makes the range complete. It also prevents future operator from guessing whether the missing data means no discount or a configuration gap. Bounds are inclusive. That means tier 1 ends at 249 and tier 2 starts at 250. Never use 250 in both tiers. Never leave a gap if the policy needs continuous coverage. Three rules protect the data. First, tiers with the same effective date cannot overlap. Second, consecutive tiers should have no gaps when the policy intends continuous coverage. Third, the product selling model, schedule, currency, and effective dates define the uniqueness context for a tier. When a pricing result looks wrong, start with the table, inspect lower and upper bound, effective dates, selling model, product, and schedule status. Do not start by changing a procedure or a price book without proving that tier data is correct. The best pricing debugging is based on expected calculation at the boundary. We will do that next. At 249 endpoints, there is no discount. So the net unit price is 240 and expected price is 59760. At 250 endpoint, the entire eligible quantity receives 15% off. Net unit price becomes 240 times 0.85, which is 204. The extended price is 250 times 204, which is 51000. At 300 endpoints, net unit price remains 204 because the policy is still in the 250 plus range. The extended price is 61200. These values are our acceptance test for episode 5. If a simulation at 250 shows 249 units at 240 and 1 unit at 204, then a slab-like approach was configured or invoked by mistake. The schedule and tiers store the volume policy. A pricing procedure will later perform a sequence, map transaction data to context, retrieve list price for product plus price book plus selling model, look up the applicable volume tier, apply the adjustment, and expose the price waterfall. The data layer remains editable under governance. The procedure remains the reusable calculation flow. Keeping the business policy visible as tier records avoids burying discount inside opaque logic. For now, do not test a quote and assume the data applies. An active schedule is necessary, but without the appropriate pricing procedure and mapping, a transaction does not automatically consume it. The safe sequence is to create schedule inactive, add all tiers, validate bounds and context, activate schedule, then use the organization approved pricing data refresh process. If a schedule is active and you need to modify tiers, deactivate it first, make a control change, validate it, and reactivate it. Records who perform a refresh, when and what result they observe. This matters because source records, pricing lookup data, and the runtime catalog can become temporarily out of sync. Do not say that runtime calculation is verified until the pricing procedure simulation in episode 5 passes, that 249, 250, and 300 cases. Let's look into Salesforce. We'll go back to Salesforce. We will have an app called Price Management. We have a price adjustment schedule by name Cumulus EdgePoint Volume Discount. The description is 15% range volume. The adjustment method is range. Price book is standard price book. If I look at the price adjustment tier, there are two tiers. The first tier lower bound is 1 till 249. Tier value is 0. tier type is percentage, and the second one is 15%, lower bound is 250. Now let's look at the lab also. So in the lab, we will first confirm that there's a product and the product term is based yearly selling model. Then in the pricing schedule, we will create a new pricing schedule. For example, if you go pricing adjustment schedule, you can create a new pricing schedule over here. You can put the effective date, active. You can select the method as range or slab. Then once we have created the price adjustment schedule, then we will create the tiers. So for example, if I want to create a tier, I can go ahead and create a tier over here. I'll select the product, I'll select the tier type, tier value, lower bound and upper bound. So we are going to create two tiers. That's what you have to create in your own org. And afterwards, you will come back and activate the schedule. So I go to pricing adjustment schedule. You can come and make it active. Then this is just a manual test that you should do to calculate whether the range is working fine. And then you are done with your lab. Let's go back to the slides. Now let's recap what we have done so far. So the cumulus volume policy is now stored as pricing data. A range volume schedule, a 0% base tier, and a 15% to 50 plus tier. The policy is complete, consecutive, and auditable. In the next episode, we will create and simulate a pricing procedure that retrieves the baseline list price and applies this schedule to transaction quantity.